NASA's James Webb Space Telescope has completed another critical mirror alignment step, and has released the highest resolution infrared image ever taken from space. Less than 2 months ago, the James Webb Space Telescope took its first photos in space. The images were taken of the star in the constellation Ursa Major, and displayed Webb's 18 mirror segments, which were not yet aligned to create one clear image. Scientists working on Webb have spent the past 2 months, making small adjustments to the mirror's alignments, to produce one unified image from the telescope's NIRCam instrument or primary imager. On March 11, NASA announced the completion of the fine phasing stage of alignment, the second of 7 increasingly microscopic stages. This critical stage is very close to the final stages of alignment, but small adjustments will still need to be made. Ground controllers have been working for months to align the segments to within a few nanometers, billionths of a meter, of one another. It may be late summer 2022 before all of Webb's instrumentation is fully calibrated and ready for use. However, upon completion of fine phasing, a new photo from deep space was taken and released. Even though Webb's alignment will require additional adjustments in the near future, NASA claims this photo of Star 2 MASS, with Webb's mirror segments in near-perfect alignment, is the highest resolution image ever taken in space. NASA released a statement explaining how JWST is performing even better than expected. Every optical parameter that has been checked and tested is performing at, or above, expectations. The team also found no critical issues and no measurable contamination or blockages to Webb's optical path. The observatory is able to successfully gather light from distant objects, and deliver it to its instruments without issue. Thomas Zurbuchen, the Associate Administrator of NASA's Science Mission Directorate, stated that, more than 20 years ago, the Webb team set out to build the most powerful telescope that anyone has ever put in space, and came up with an audacious optical design to meet demanding science goals. Today we can say that design is going to deliver. It will be months before Webb is able to deliver actionable, calibrated images of the cosmos, but scientists and fans of the project alike are already hopeful and excited to see what Webb discovers. According to NASA, the next 6 weeks will be spent commissioning, calibrating, and testing complex scientific instruments, including the near-infrared spectrograph, mid-infrared instrument, and near-infrared imager and slitless spectrograph. In this phase of the process, an algorithm will evaluate the performance of each instrument, and then calculate the final corrections needed to achieve a well-aligned telescope, across all science instruments. NASA claims the Webb team is on track to conclude all aspects of optical telescope element alignment by early May, if not sooner, before moving on to approximately 2 months of science instrument preparations. If all continues to go according to plan, Webb's first full-resolution imagery and science data will be released as early as this summer. Webb is the world's premier space science observatory and once fully operational, will help solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it. Webb is an international program led by NASA, with its partners at ESA, European Space Agency, and the Canadian Space Agency. But what next for James Webb Telescope? How did this universe begin? Were we alone in this huge cosmos before the Big Bang? Just some of the numerous questions that scientists have been pondering for years. Like this one. They planned a slew of projects and missions, to gather as much information as possible about our origins in the universe we live in, but no technology existed to do it. The James Webb Space Telescope, a large telescope, was then built by scientists and is expected to help us understand the origins of the cosmos. But the real question is, can this JWST achieve it? Is it possible that James Webb will be able to see thousands of light years into the future? We'll be discussing this. In today's video, a new era of astronomy is just around the corner, provided everything goes according to plan. After a nail-biting launch on Christmas Day, the James Webb Space Telescope has launched its mission to capture the birth of the universe. James Webb Space Observatory will be NASA's largest and most powerful space research telescope, exploring the cosmos to learn more about the universe, its history from its Big Bang to the birth of alien planet. And beyond. The observatory will cost $10 billion. It is part of NASA's great observatories, which comprise the Hubble Space Telescope and other massive space telescopes that can stare into the universe. What if JWST primary goals is exploration of galaxy formation, more than 13.5 billion years before the Big Bang. A hitherto UN-observed period of cosmic history, that formed our universe as we know it today. According to NASA, JWST was built to observe a time in the universe's history that has not yet been observed before, rather than to study the origins of the cosmos. We prefer to think if the JWST is a successor to the Hubble Space Telescope, rather than a replacement more than 30 years after its launch. The Hubble Space Telescope has provided us with a breathtaking views of the universe and countless scientific discoveries. It is our hope and expectation that it will continue for many more years to come. However, the Hubble telescope's 2.4-meter diameter mirror, compared to a ground-based telescope's lenses, sensitivity and ability to observe the faintest objects. This is a limitation. Even though Hubble can observe infrared light, it cannot access the light wavelengths from the very first stars and galaxies. Hubble has some capability to observe infrared light. JWST, on the other hand, will be able to do this task for the very first time. We may even be able to observe stars that were generated from primordial material, from the Big Bang. Knowing when and how the first stars originated soon after the Big Bang is an important scientific subject and one of the key science teams of JWST: carbon, silicon and gold, which are essential to life and contemporary technology, were produced in the early stars. But how they did so is still a mystery. As a result, the design of this observatory has been influenced greatly by the fact that it needs to be extremely cool to reduce the amount of unwanted background light. It's not just the initial stars and galaxies that will be studied by JWST. Researchers from all over the world can apply for time at this observatory, which is designed to serve a variety of purposes. Infrared observation will allow JWST to see through the clouds of dust that enshroud very young stars, which are impenetrable to the visible light of the telescope. That means it will be able to see directly into star-forming regions, something Hubble hasn't been able to do yet. The findings will shed light on the formation of stars, and the systems of planets that orbit them. Did the universe we observe today, but the Webb telescope will help us answer these critical issues. The first galaxies will be discovered using near-infrared surveys, followed by low-resolution spectroscopy and photometry in the mid-infrared. Researchers will need to use high-resolution near-infrared spectroscopy to observe things that have never been seen before. Thanks for watching this video, and it's a super interesting topic. If you like this, make sure to subscribe. If you have any crazy ideas about what we should cover in next video, please comment it below, and we'll see if we can get to it. So thanks again for watching and goodbye.